Hello, my name is Lauren, and today I will be explaining how to do the unit circle and find its coordinates. This is video part 3 of 3. Let's get started. For this video, I'm going to re-explain which quadrants are positive and negative along the x and y axis. As you can see here in quadrant 1, the x and y axis are both going in the positive direction. In quadrant 2, the y-axis is still going in the positive direction, although the x-axis is now traveling in the negative direction. In quadrant 3, the x and y-axis are both now traveling in the negative direction. In quadrant 4, the x-axis is traveling in the positive direction now, and the y-axis is still traveling in the negative direction. Let's start off along the x-axis on the horizontal right here, where we have 0 degrees and 0 radians. In a unit circle, we will always have a length of 1, meaning the x-axis in this case would be 1, and the y-axis would be 0, as we do not move on the y-axis. We only move along the x right here. So the first coordinate we can fill in here is 1, 0. On the opposite side here, where we have 180 degrees, we can see that we have the same scenario, where we are moving over on the x-axis in the negative direction, meaning we have -1, 0. Now we can fill in the 90-degree angle. As you can see, we move up 1, and we do not move along the x-axis in either direction, meaning our point would be 0, 1. For the 270-degree angle, as you can see, we also move along the y-axis, but not along the x. Although in the y-axis, we move along the negative direction, meaning we would have 0, -1. Now that we have the coordinates for all the 90-degree corresponding angles, we can fill in the first quadrant's coordinates. Let's think of this 45-degree angle as a triangle. We rise and run a certain amount within this triangle, meaning we have some sort of slope for this 45-degree angle. You rise with square root over 2, and you also run with square root over 2, meaning the coordinate would be square root 2 over 2, square root 2 over 2. Now that we know 45 degrees or pi over 4 is square root 2 over 2, square root 2 over 2, we can now do the 60 and 30 degrees. In order for the coordinate of the 45-degree angle to make a little bit more sense, let's put it into context of a triangle. As you can see, the hypotenuse of the triangle is 1, due to the radius of the unit circle being 1. We can use the Pythagorean theorem in order to figure out what the x and y axis are of this triangle. As you can see, we have a squared plus b squared equals c squared, and we know that the hypotenuse or radius is 1, so we have 1 squared right there. We know that a squared plus b squared has to be the same due to a 45-degree angle being on either side. So we have 2, and we change the variable into an x squared is equal to 1 due to us combining the a plus b squared and us moving the 1 down. So we divide by 2 in order to get x squared by itself. Then, once we get x squared by itself, we can square root both sides, giving us x equals square root of 1/2, or square root of 2 over 2. If you put both of these numbers into a calculator, you will be able to see that you get a number that is extraneous, approximately 0.707, which is how we get the coordinate of root 2 over 2, root 2 over 2. Now let's move on to solving the coordinate for the 60-degree angle. As you can see, our radius is still 1, and we can see here that this is half of the length of this 1 on the x-axis, meaning when we plug these numbers into the Pythagorean theorem, we can use 1 as our radius and 1/2 as our a or b. As you can see, we have 1/2 squared plus b squared equals 1 squared. Then, as you can see, we end up with 1 over 4 plus b squared equals 1. You subtract the 1/4 from either side in order to get b squared by itself. Then you have b squared square root both sides, so you get b square root of b squared equals square root of 3 over 4. And finally, you get b equals square root of 3 over 2. Meaning in this case, the coordinate for the 60 degrees or pi over 3 is 1/2 comma root 3 over 2. Now, using the right triangle here, we can solve for the 30-degree coordinates on this unit circle. Our radius is still 1, and as you can see, instead of our x-axis being cut in half, we now have our y-axis being cut in half, meaning this side on the y-axis is 1/2. Using the Pythagorean theorem again, we plug in 1/2 and 1, the same as last time, and we end up with root 3 over 2 again. Although in this case, our x-axis would be root 3 over 2, and our y-axis would be 1/2, giving us root 3 over 2 comma 1/2. Now that we have quadrant 1 filled in, we can move on to our other 3 quadrants. Once you have quadrant 1 filled out, it is quite easy to fill out the rest of the quadrants. The other quadrants build off of quadrant 1. So if you remember quadrant 1 and its coordinates, you will be able to solve for all the rest of the coordinates in the other quadrants. As you can see, we have quadrant 2 filled in. We have negative 1/2 comma root 3 over 2 as a reference angle of 60 degrees. We have negative root 2 over 2 comma root 2 over 2 as a reference angle to 45 degrees. And we have negative root 3 over 2 comma 1/2 as a reference angle to 30 degrees. As you can see, all these coordinates are just a reflection upon the y-axis of the coordinates in quadrant 1, although the x-axis is now traveling in the negative direction, therefore meaning the x positions in the coordinates are now negative. Now we have quadrant 3 done. We can see that all of these coordinates are exactly the same as quadrant 1 and 2, although they are both in the x and y axis traveling in the negative direction, therefore meaning the coordinates for both the x and y are negative. Finally, in quadrant 4, we can see all these coordinates are exactly the same as quadrant 1, 2, and 3, although the y in this case is traveling in the negative direction, therefore meaning the y coordinates are going to be negative. As you can see, this is the fully completed unit circle with its degrees, radians, and coordinates. If you would like to see how to find the degrees or radians within this unit circle, refer back to part 1 and 2 of my videos. Thank you for watching and see you back next time.